Let me record here. I start recording. So, okay. But for like messages and text messages, like, for instance, that week that, it was off, right? Because of the 19th or whatever, right? So, do you guys prefer Discord, right? Because, this is my experience with Calpoli. Maybe I'm wrong. Majority of the time, even if I send message through the canvas, nobody read it. That's what I noticed. Maybe I'm wrong, but this is based on statistics. So you guys all the time on Discord, that's my question.
Yes.
Yeah,
Okay.
we're always on Discord.
So, from now on, every chat will be Discord, and then, that recorded videos are gonna be like a link for YouTube. Okay, once I'm done, I will load it on my channel, then I will just pass the links through the Discord. Make sense? The second thing that I received during the last week, somebody asked me for the lab to be written. So are you guys convenient with that, or are you convenient with visualizing stuff like the way that, with blocks and stuff like that? Because I know some people give people code and just tell them go run it. That's what I heard. But, I don't think that would be the smart way. I think the best way is actually for you to code, to make code by your hands.
I think the way you did it on the first lab, the way you wrote it on Teams was like at least perfect for me, at least.
Okay, that's fine.
Same.
That's
I
fine.
prefer that.
Okay, so you want it to be like written instructions, right?
I say you use Teams to write the instructions only, and then we use Discord to communicate with you.
Okay. So I will go ahead and I put it on Discord for both. Sounds good. And instead of going in Teams, whatever is convenient for you guys. Anyway, so let me actually write down the instructions. So the instruction, you guys are using Nexus, right? A700T, right? Nexus A700T. One second, because I'm writing some notes and I'll generate for you like a little report. Build an experiment. A minute and it'll be ready for you. Okay. So can some of you guys in the chat actually send me a text for the link of the Discord so I can start writing the instruction on the Discord? Can you put like, the link for the Discord channel in the text message? Okay, thank you. Let me share my screen. Cheer. Everybody can see my Discord?
Yes.
Okay. That's a lab 3 or lab 4? I think lab 3, right? Lab 3, right? Hardware required is Nexus A700T, right? parts on the board to be used as the first digit on the 7-segment display. The lab focuses on creating an up counter BCD/hex. So we're gonna be building a counter. That counter, it has a signal. That signal, it can be, if it turn high, that counter will tend to be what? Up BCD. You know what's BCD up counter, right? To do that, you need one signal called selector, which if it is high, the counter will act as BCD, which means counting from 0 to 9. On the other hand, if the selector goes down, the counter will be counting from 0 to F. In addition, you will use another signal to act as an enable for this counter. If the enable is high, the counter will be counting, and if it goes down, automatically the current status will be an idle. Everybody can see what I wrote or not?
Yeah, we can see it.
Okay. So far, do you have any question?
I have a question.
Sure.
In terms of just grading the labs in general, are you posting that on Canvas, or are you gonna like maybe get feedback
They're
on
gonna be Canvas. Automatically, you will see your grades. I already made
Okay.
like columns for every single lab, right?
And will you give any feedback on GitHub, like on our code that we post at all, or no?
I'm looking into it. I wrote some notes on the side. I will start like sending messages to people if I see there is something wrong.
Okay, sounds good. Thank you.
Thank you. So far, is the lab 3 is clear?
Professor, I have a question.
Sure.
So when we use the select, I'm assuming that's one of the switches.
Yes.
Will we have to be using a decoder for the hex part of it? Because I think 0 to F is like 15 switches, correct?
No.
Or
No. Basically, think about it like this, right? It's a 7-segment display. We are not turning on all of the 7-segment display, right? We're just turning one digit. Do you agree?
yes.
So that digit, it can be controlled by 4 bits. You know why? Because it can create 0 to F, right? So if I'm you, what I'm gonna do, I'm gonna build the decoder for the 7-segment display to 0 to F. It's a display, right? It's like a TV connected to PlayStation, right? The TV showing us what's going on because it's connected to the PlayStation. You understand what I'm saying? So
Okay, I see now.
the whole entire trick, it's gonna be inside the module is called counter, right? Because what will be the input to the counter from your point of view? It will be the clock, right? And it will be what? It will be the enable, and it will be the selector, and it will be reset. Because counter is a sequential, right? So I can write it down here. Note, up counter needs the following by default due to the definition of counter, right? One signal will be clock. One signal will be reset. one signal will be enable and one signal will be selector, right? Now there is something you need to think about, right? What about if the enable is high, is low, but the selector 1 or 0? What will happen in this counter? Do you have any idea? Hello?
Can you repeat that real quick? Sorry.
Again, so let's say that, I'm running my counter, right? It's already on the board or test bench or whatever, right? And I turn on the selector to be 1, but the enable is 0. What will happen?
Will it just be running at BCD?
No, it will not be
Oh.
running at all.
Oh,
Enable
okay.
has the higher priority. So it's a kind of it's a sequential behavior. Do you remember the blocking, non-blocking? I was saying, well, actually, I talked to you like, 10 minutes or 15 minutes ago. So there is something it's called sequential thing, right? So, here, I'm gonna make a small example, but I'm not gonna give you everything because, it's a lab, right? So I'm gonna turn on my Vivado and I'm gonna show you some example, okay? Vivado is turning on. Takes forever. It's opening. One second. Okay, now I'm gonna turn on my near share. Everybody can see my screen, right? So I'm gonna come and say create a project, right? I'll say next, and this one I will just call it what, up counter. And then I'll say next RTL. It's a Verilog, and then I'll say here next. It's not important at the moment, the constraint file. And here I'm gonna come and say what, XC7A100 TCS minus, which is basically the chip name of the Nexus, right? And then I close. Can you see the screen?
Yes.
Okay. Now I'm gonna say add source because it's gonna be the source that we're gonna create, right? So it's a counter. So I'm gonna come and say here, up counter, and then I'll say selects finish. And here, I'm gonna start stating all of my what signal, right? So it's clock, reset, enable, selector, right? And then those all of them are input. Then I need an output, and the output here is gonna be what, OP, for instance, and gonna be a 4-bit, because it's actually 4-bit BCD, because BCD representing in 4-bit, and even in hex is 4-bit, right? And that's it. So here is it's supposed to be coming out. It's a little bit slow, but anyway, the counter's skeleton is coming out, right? So you can see now in the side that the skeleton came, right? Here is the module for the counter, right? Then it's a counter, so pretty much I cannot use the output to be part of the counter. So I have to make a temporary register. They're gonna act as what? Rig and 3 to 0, and then I call temp. Then I will make my always block as I showed in the videos before. So always at positive edge of the clock, begin, end. What you need to do, you need to implement the process, right? So what is the process? Is if reset is high, what I'm expecting the counter to be 0, right? So temp equal 0. Do you remember this sign I mentioned?
That's unblocking, correct?
Exactly. Yes. And then I'll go here, else. And then I will say what? Else what? So the reset has the upper hand, the highest priority. That makes sense? So if the reset happen, and the enable happen, and the selector happen, who is the winner?
Would it be reset?
It will be reset. Okay, if the reset is not happening, but enable happen and the selector happen, who is the winner?
You said enable, right?
Enable. But then who has the lowest priority?
Would be the select.
So what did we implement now? We implemented what? Priority encoder. Right? Because one has higher rank compared to another one, The lowest in the rank is a selector, right? The highest in the rank is a reset. The one mid-size is enable. So the trick that when I said else, that give the upper hand to the reset. Now the next is gonna be what? If enable is high, if enable is high, I have to go and make begin and end in this case. Why? Because I'm gonna write a lot under this, right? And pretty much it's better for me also to go here and begin and end, because else is actually had bunch of what? Line under it. Otherwise it's gonna fail. So technically, we have to do it like this. Okay, now if the enable is high, I'm looking for something, right? But if the enable is low, nothing will happen, so I don't care. You agree? But the selector now is the one that's coming, right? So who's gonna be after this? If selector is high, right? Then I can come and say begin, end, and else of it, begin and end. All of this in front of you is a skeleton of what? Priority encoder. So now I will go into the selector. If my selector is high, right? So pretty much I'm what? I'm BCD. Do you guys agree? Right? I mean, that was written in the Discord, right? Did I say if the selector is high, what will be the power? If the selector is high, the counter will be BCD. That's true. It will be BCD. So in that case, I will just come and say what? BCD, that means I will never count to 10, right? I will just count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I go back to 0, correct? So in that case, I will just say what? If selector is high, then I will say what? Temp equal temp plus 1. But that's not entirely correct. Because, you know, if this happened, I will actually reach to 15, then I will go back to 0. That makes sense? So in that case, I have to say what? If temp less than 9, do this. Else, temp will be 0. Why this happened? Because, you know, when it's less than 9, automatically the next cycle temp will be 9. So 9 will happen. Do you agree? Now, the else of it is just what? Normal count. We are done. Here is our what? Up counters. BCD or whatever. Somebody will come and say, but you just make 10, but the output is OP, right? Then I can just say assign OB equal 10. We're done. Here's your count. Any question? Do you guys have any problem?
Can you explain the initial like if statement with temp less than 9? I'm
Okay.
not quite understanding.
Why? Temp, it's a 4-bit, right? If I just say
Yes.
temp equal 10 plus 1, automatically it will cover all of the possibility of the 4-bit. What is the possibility of 4-bit? 0 to 15, right?
Yes.
But the selector, if it's high, I will never reach more than 9, right? Because BCD. What is BCD? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So in that case, I'm saying even though my selector is high, just be sure don't go more than 9.
Should it be less than or equal to 9 or just less than 9?
If you say less than equal to 9, then you know 10 will come out to you. Because, you know, listen, you control next cycle you execute. You understand? So you control here, right? You said less than 9, right? That's it. Next line will do what? Will take the 8 plus 1, it will make it 9.
Oh, okay, I see now.
Then the next it will be what? Oh, other 0. So gonna be 0, 1, 2, 3, 4, 5, 6, 8, 9, 0. That's why is what? The blocking, non-blocking, remember?
Yes, yes.
Is it clear to everybody here? Any question? Any concern? Any problem? Let's go back to the Discord so we can write how I'm gonna be grading you. From your point of view, what is missing here to make this project is done? You can make a top module. I mean, you're gonna make 7-segment display, which is really nothing, basically. I already give it in the code in the video. Then, you know, you're gonna make this 2 sub-module, right? You make a top module, you instantiate both of them, you connect them to each other, and the rest it will be connected into the XDC, and that's it. Right? Make sense?
For the up counter, is that code just for the BCD, right? And then you'll make a separate up counter, or we would have to make a separate up counter for the X, or can you do both in one?
This code is for both.
Oh, it's for both. Okay.
That makes sense?
Yeah.
So can you tell me why for both?
Is that because it depends on the status of the selector switch? So it'll automatically
Exactly.
go through, okay.
Exactly. And the crazy thing, if you change the selector in the middle of the count, right? And the next it will correct itself. What does it mean? Let's say that I'm counting and I choose the selector to be what? Hex. So I came into the state that I see in my 7-segment display 10, right? But then, because 10 in hex is what? A, right? Then I push the switch to be what? BCD. What will happen? Next cycle,
Well,
start from 0.
yeah.
Exactly. There is another thing here, and this lab is not clear. You know what? This clock inside the XDC is 100 megahertz. So if I run this counter 100 megahertz, and then I connect the 4-bit output to the 7-segment display, what will happen to me? I will not see anything. I'll just see fixed number on the 7-segment display. Do you know why?
There's no delay for the numbers to display for us to
It's not
actually
about
see.
delay. It's your eyes will not the perception system is not working in the brain to handle 100 megahertz. Your eyes see stuff in kilohertz. So what is the solution? You know what is the solution? Clock divider. Have you heard about the clock divider?
Oh, so it's gonna use like shorter clock sequences
So
or
I
like
can tell
divide
you,
up.
there is 2 ways to make a clock divider. One of them, it's systematic, which is 2 power n-ish. What does it mean 2 power n-ish? It means the following. It means that I have 2 power n, and in the 2 power n, the counter, every single bit in the counter is considered a clock. Did you know that? So if you have a 4-bit counter, right? Bit number 0 in that counter, right? How often it will be changed every cycle. The second bit, how often will be changed every 2 cycles. The third bit, how often will be changed every 4 cycles. The fourth, it will be how often it will be changed every 8 cycles. So it's 2 power n of the position, right? So what you can do, you can actually create a big counter. Let's say 32-bit count, up counter, just normal up counter, right? Then I will take all of the 32 wires coming from the counter and I feed them to a multiplexer. Then the selector of the multiplexer will select which one to be represented as a clock. Then that clock will be connected to the clock of the counter connected to 7-segment display. Then you can play with the speed. You hear what I said? You hear what I said?
That was for an example with like a 32-bit though, right?
I mean, normally you should make it like that. Because 32, then because you already have a bunch of switches. Do you agree? I mean, think about it, right? Now you have a switch for the select. Do you agree? Then you already
Yeah.
have a switch for the enable, right? A reset, I don't think you're gonna make it a switch. Make it button. Because you're not gonna be resetting forever, right? Just button like this, right? So how many switch left out of 16s?
So you said we're using what, 3 of them? You said so.
Selector,
13.
selector, enable. That's it. The
Oh,
reset is
sorry.
the button. So we have 16 minus 2, we have 14, right? So take from this 14, 5 to be what? A selector to the power management. We call this power management, right? Why? Because it said 2 things. 32-bit up counter combined with a multiplexer. The output will be the official clock that I will be connected to the up-down counter the up counter that we just created. Do you want me to draw it in front of you guys?
Sure.
Okay, let me just pick up my iPad. Yeah, just need 1 minute to be synced. And then, I can draw it in front of you. But anyway, let's go back to the Discord so we can write down the rest of the spec. And then, by the time the iPad will just like get synced, I will start sharing the screen. So stop sharing and go back to Discord. Due to the eye limitation with the speed of changes, the 100 megahertz used by the provided oscillator on the board needs to be delayed by building a clock divider. To do so, you can create an up counter 32-bit and the output of this counter will be connected to 32x1 multiplexer, which means 5-bit switches will control such a mux. To draw in mind the whole top module, you will think as follows. 1. The up counter BCD/hex needs one button to act as reset, while the selector and enable will be presented as switches. 2. 5 switches will be used for controlling the speed of presenting the state of the counter on the 7th cell. You can design the lab based on 3 sub-modules: display, up, BCD, hex counter, and combination of the 32-bit counter plus mux to act as a speed control. To grade this lab, we will follow the same procedure as last week. 50% on your demo, 25% on your test bench and 25% if you present in on Zoom. But if you decided to load everything without presenting on Zoom, you will get 50% on test bench. Okay. Do you guys have any question regarding the instruction written on the Discord? Any question, any concern? Hello?
I think we'll be able to figure this one out. We'll see.
Learn by doing.
It's easy, right? I mean, I showed you the counter, right? This is the only thing that, you know, it's actually gonna take time, which is no longer gonna take time. Okay, now I'm actually going into the
So essentially each selection is gonna basically feed a different multiplexer, which has a different counter division for this feed.
no, I will show you now. I'll show you now. Just you know, I'm gonna give you now every single information, you know, because you know I turn, you know, the iPad is already what synced, so you know, I'm gonna start drawing in front of you, and it's gonna be easy peasy lemon squeeze. It's too simple. How can I share my screen? Let me see. Share my screen. Share content, share screen. Start broadcasting. Can you guys see my my board? I mean the whiteboard. Okay. So you know you have 3 boxes, right? Here is a box. What the heck? 1 second. It's a recharge, so what's the problem? So here's a box in front of you, and that's called Power Manager. The Power Manager has a clock, has a reset, and it has 5 switches to control the speed, right? And 1 output here, which is basically what the clock, correct? If I would like to know what is inside this, that's really simple, right? It's a counter. The counter is a clock. The counter is a reset. And it has what? 0 to 31 output wires. Then that will go inside a multiplexer like this. And this is a 5-bit switches that we're talking about. And here's the clock. Is it clear? Here's up. Count. The part's clear now. Any question? How this will be connected in the whole thing, right? Now, do you remember the counter that I just created for you guys? So that counter is here, right? Here is our counter, correct? Our counter was what? Clock, reset, and enable, and what selector, right? Then we have here 4 output, which is a 4-bit. How I'm gonna be connected? I could actually do this, connect it like this. And this is what up counter BCD hex. Then here is what your 7-segment display. The input of it 7-segment display, it's gonna be here the connected, it's gonna be clock, it's gonna be the reset, and it's gonna be what? The 6 to 0, which is basically the CCA, CCB, CCD, CT, whatever. And it will be connected the AN and the DP, which is the decimal point, and that's it. And if you combine all of this together, they're gonna be what the top file. 7-segment. Any question? So if you think about it, how many reset we have, right? So we have a reset for the power, right? We can actually combine all the reset together, and they're gonna be also what button. So in reality, you have here 5 switches for the power. You have here 2 switches for the selectors and the enable. So 5 plus 2 is 7. And then you already have 1 button for what representing all of the reset. Easy. Tell me if you have any problem. Hello. Any question?
Professor, is the
Yes.
up counter, like both of them, the BCD and hex, and the one you drew initially, those are all connected, right? Those are all the same up counters?
No. This did you see? Up counter BCD hex. Right? This one is just up counter. Is there any selector here or any enable or anything?
Oh, okay.
It's
So it's a
another
different
module.
one?
Yeah, it's
Yeah.
another module. Just let's clock and reset, right? You understand what I'm saying? How are you gonna do this? That's very simple, man. Look here, module, right? Counter here, right? Input, clock, input, reset, output, count, and that output is what 31 to 0. Then I will create temp, right? So it's here reg 31 to 0 temp. Then I will say here always at pulse edge of the clock begin. Then if reset is high, temp it will be 0. Else temp it's gonna be temp plus 1. And then this begin it has to be end here, and that's it. It gives you counter. Easy, right? This less than equal. Any question? Then you're gonna come here and say what? Assign count equal temp. Any other problem? Hello? Hello. Is it clear, guys?
Yeah, it's clear.
Okay. If it's clear, everything is fine. This is a new lab. And the deadline is gonna be the next time, they're gonna be next week. You guys gonna show it to me and so on. So before we close the part, if any question, any concern regarding this, let me know, please. The writing is already in the Discord. Recorded video, once will be done, I will be loading it now. So any problem? Is there any problem, any concern so far?
No problems, Professor.
Perfect. So in that case, we're gonna take like a 10-minute break so I can load the video, and then after that I'll come back for anybody has any problem with the previous labs or anybody would like to show me his labs. Sounds good?
Yep.
Okay. So see you in 10 minutes.
Thank
Thank
you.
you. Thank you. Bye-bye.
Wait, Professor, I have a quick question.
Sure.
So in the Discord, you said that we will have 5 switches to control the speed of the clock. So total, we need 9 switches. So 5 for the timer, and then 4 for like the clock enable selector and then reset.
Reset is not switches. Reset is gonna be buttons. How many buttons do you have? We have 5 buttons on the board, right?
Yeah.
So, you see in front of you here, right? Here is the final design, correct? Clock is
Yeah.
clock, right?
Uh-huh.
Reset here, we can connect it with this reset. We can connect it with this reset and just take one wire out it and it's gonna be a button. So just one button for all the resets for the top module, right? Then you already have 2 switches here, enable and selector. And then you already have here 5, so 5 plus 2 is 7. 7 out of 16. So we still have 9 free.
Okay.
That makes
Okay.
sense?
Yeah. Got it. Oh, that makes sense. Yeah. Thank you.
You're welcome. Any other question before I start preparing the video for YouTube? No other questions? Okay, guys. So, I'll see you in 10 minutes. It's already now 2 o'clock, so 2:10 I'll back, okay? 2:10. Once, the video is already the Zoom is already compressed it. Okay, Luke? Sounds good? Hello?
Sounds good, Professor.
Okay, see you guys in 10 minutes. Thank you. Bye-bye.